Good morning everybody and welcome to Advent of Code Day 22. Sorry. People are getting sick at home, so I might be coming down with something as well, but I still feel good enough. Yesterday evening I did another stream trying to get part 2 for day 21. And I got pretty far. I got some cases working, but not all of them. So I had to abandon the attempt for them to make sure that I get some sleep. So I might revisit it later, but let's first try day 22 now. Because I still think my idea has some merit and would be cool to work out even further. But as always, there is a simpler solution that I might have to go for in the end. But yeah, it was fun chasing this idea of all the patterns and making a general solution, which I think is pretty cool. So yeah, let's start reading day 22. Sand slabs. Enough sand has fallen, it can finally filter water for Snow Island. Well, almost. The sand has been falling as large compact bricks of sand, piling up to form an impressive stack here near the edge of Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nay, disintegrated, back into freely flowing sand. The stack is tall enough that you'll have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong bricks, large portions of the stack could topple, which sounds pretty dangerous. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling, your puzzle input, which would let you work out which bricks are safe to disintegrate. For example, so this is the sample input. Each line of text in the snapshot represents the position of a single brick at the time the snapshot was taken. The position is given as 2 XYZ coordinates. Okay, so this is operating in 3D, that's funny. I just made my 2D grid. I think I might need to upgrade to a 3D one. One for each end of the brick, separated by a tilde. Each brick is made up of a single straight line of cubes, and the elves were even careful to choose a time for the snapshot that had all of the free-falling bricks at integer positions above the ground. So the whole snapshot is aligned in a 3-dimensional cube grid. A line like 2, 2, 2, okay, it means that both ends of the brick are the same coordinate. In other words, the brick is a single cube. This one, hey Luke, good morning, welcome. Lines like 0010, 1010, let's see, both represent bricks that are 2 cubes in volume, both oriented horizontally. Okay. Ah yeah, okay, differ by 1 and differ by 1 here. Okay, that is fine. The first brick ends in the X direction, while the second brick extends in the Y direction. A line like this represents a 10 cube brick, which is oriented vertically. One end of the brick in the cube is located at Z, while the other end, okay. The ground is at Z is 0 and is perfectly flat. The lowest Z value a brick can have is therefore 1. Okay. So 551, 561, okay, are both resting on the ground, but this one was above the ground at the time of the snapshot. Because the snapshot was taken while bricks were still falling, some bricks will still be in the air. You'll need to start by figuring out where they will end up. Bricks are magically stabilized, so they never rotate, even in weird situations where a long horizontal brick is only supported on one end. Oh, this is funny. So you're basically building 3D Tetris here. Captain Coda will like this. Only supported on one end. 2 bricks cannot occupy the same position, so a falling brick will come to rest upon the first other brick it encounters. Here's the same example again, this time with each brick giving a letter so it can be marked in diagrams. At the time of the snapshot, from the side, so the x-axis goes left to right, these bricks are arranged like this, okay? Rotating the perspective 90 degrees so the y-axis now goes left to right, The same bricks are arranged like this. Okay. Once all the bricks fall downwards as far as they can go, the stack looks like this, where question mark means bricks are hidden behind other bricks at the location. Sure, again from the side. Now that all of the bricks have settled, it becomes easier to tell which bricks are supporting which other bricks. A is the only brick supporting bricks B and C. Brick B is one of two bricks supporting brick D and E. G is the other one, D supports that, blah blah blah. Okay, your first task is to figure out which bricks are safe to disintegrate. A brick can safely disintegrate if, after removing it, no other bricks would fall further directly downward. Don't actually disintegrate that brick, any bricks, just determine what would happen if. For any brick, only that brick was disintegrated. Okay. Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze between bricks if you need to. Okay, this is a fun, very fun challenge, but not one that will be coded quickly, I'm afraid. Let's see, in this example the bricks can disintegrate as followed. Yes, okay. Because it supports two, sure. So both of these, but not at the same time, that is fine. And I think maybe part 2 will be that you actually do disintegrate them and then see which combination will let you get rid of the most of them or something. Yeah, this is fun. Okay. Let me see, figure out how the blocks will settle based on the snapshot. Once they've settled, consider disintegrating a single brick. How many bricks could be safely chosen as the one to get disintegrated? Ah, okay. So maybe there's one where you have to do 2 or 3 at the same time. Okay. Interesting problem for today. I like it. So it's X, Y, Z. Now I need to make sure that I need to get back to this and see how they do their X, Y, Z. So Z in this case is actually the what you would normally have, the Y-axis. So that is the Z-axis normally. So I think they might have like this one would be Z, this one would be X, and then the depth one would be Y. But I'll have to check this in a bit. Let me see. Let's start coding. Day 22. 22. Okay, Jesus. Day 22. Okay. Let's do, and I have my grid here. Let's do a record for XYZ as well. Public record. Location 3D. And this can just be int X, int Y, int Z. I will have some operators for that in a bit. Let me see, do I have a parser for this? So I could do like public record brick would be location 3D for a location and another location 3D for size. Public let's make this a string raw. That is annoying. This is why I usually do it differently, and I do this. So I will have the record here, and then I just do a public int x get init like this. And then I have a constructor that satisfies this one. Let me zoom in a bit. What did it look like? Let me just close all of this, because I have way too many files open. So will be just a comma separated values. Bum, 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 bum. I could also just make a static method called parse. Maybe that's better. Public static parse. So let's go back to the old notation and just do this: int x, int y, int z. And now I can do call it like this: parse. So we do then I can do x, y, z equals raw dot split, comma as value 2.3, and then I can do return new, and then x, y, z. But it did like this. Cannot implicitly. Oh yeah, sure. As int 32s, like this. Okay. So this one lets me parse them. Let's do the same here. Public static brick string parse string raw. We do raw dot split. Would be the tilde in this case. We can do const char location separator equals to this. Okay. Let's split on that. And this one would be new look actually it would be is location 3d.parse x, and we do that twice. So now we can do this location 3d, this will be location size, so I can do this like this, and then return new brick. So that's the parsing done, and I should probably have the separator here as well, just for clarity. So this will be value separator or axis separator, and have a comma here. So now we have our parser written, so we can do var bricks is yes, bricks input 2 lines, something like this, right? Now we make this global here so that we have it accessible to everything. Now we have our list of bricks. Okay. They're X, Y, Z. Let me see. X, Y. Okay, so this is a Y example. The first one is X, Y, but yeah, how did they... yeah, the Z is clear. Let me see. Z is 0, perfectly flat, low is Z, blah blah blah. From the side, X goes left to right. Okay, so the X is like this, Z is this, and then Y is depth. So, okay. Let me just draw it here. And I don't have the right colors because I can never remember which way. We have an X, and we have it like this. So this one is X, this one is Z, and this one is Y for this example, right? So this is how we have to look at it. Yes. Let me just put it here as well, just so that I can look it up if I need to. Left to right, front to back, down, up. Because it like 0, 0, 0, going in the X direction means going right, going Z means going back, and the Y will take you up. So this is from low to high. I can also see that going in a different direction, but it doesn't matter in this case, as long as you're consistent in that. So we need to have something that lets us figure out if we can go down. So we can do public blah lowest point, right? And this takes in a list of this other bricks. Other. Yeah, and it doesn't need to be, it needs to be, well, it needs to be on the brick actually. So I should have it like this, and this needs to be a list of brick. And basically this needs to be, you need to get every intersect. So let me just do IEnumerable brick below me. Okay, so this would be for each bar brick and other bricks. Good morning, Marte. Did you see today's challenge yet? It's a fun one. We're doing Tetris in 3D. So these are blocks, and then you have to figure out how they can fall down and how they are supported, and it's an interesting one. It might be right up your wheelhouse, right? Yeah, almost finished second part now, right? Very well. Let me drop some muscle in chat for that. Also, let me just drop the link in for today. I'll be able to pin it later. It's so annoying that you can't just... the emojis cover it. Also, by the way, something that really has annoyed me lately is I always use stream beats as the background music. Oh, claim released. Wow. They have released the copyright claim. Cool. I've been getting copyright claims for all my vids. So this is actually these two I think I just submitted more appeals on. So yeah, I should probably figure out which one of the stream beats tracks is the most likely culprit and just remove that from the playlist, but yeah. Okay, sorry for that tangent. Amarte says, plus I have a small bonus that I will show you, that will show it off when I finish. Okay, cool. Looking forward to seeing it actually. Let's pin that one. Ah, I pinned the wrong one. No worries. For some reason I can't seem to pin my own. It doesn't matter. I tried to pin the the link for today, but it won't let me. It's okay. Let's go back to coding. What I was writing up is something that will look at the other bricks and see which one is below. So if brick that location dot and doing intersections in 3D is let me think. I think I need to do it for each axis individually and then make sure that each one of them aligns. So I think if the Y Z actually needs to be smaller than Z location at Z. Make sure it's below us. So that is step one. Woohoo! Step one. We did a Z check, and now we need to make sure that there's an intersection between the X and the Y axis here. So brick.location.x. Let me do some math here as well. So I need to have an operator. So public operator. No. Sure. This one would be location.x plus yes, size.x location.y plus size.y location.z plus size.z. Yes, okay. Type expected. Okay, this one will be I can't even remember the way that I've written the operators. Let me quickly look it up. Static grid location operator. Okay, public static like this. Okay, fine. So I can do public location 3D and location. Should make these uppercase as these are the property names. It's a bit counterintuitive because it looks like parameters, but yeah, it works like that. Boom, 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 boom. Actually, I can do location 3D and location like this. It's fine, and then I can do end location. Location plus size. This. And basically this constructor should be able to do it without let's go to brick. Okay, yeah, that was the issue there. I should just have explicit constructors. It's annoying. I'll just leave it like this. It's fine. Okay. Let me see. Two. So the X needs to be smaller or equal to brick actually end location dot X and brick location dot X larger or equal than a location at X. I think this is the one. Let me make sure. Let me just make sure that I take the max of these two actually. Math.max brick.end location.z. Yes, this one actually needs to be below our current one. And I probably need to have the min of these. I will probably have to write some tests to make sure that I'm correct here. Bool x intersects is this. Y intersects is. So I should probably have a public bool z below brick over. Let's just pull it out here. Done, go, wow, congrats, nice job. I want to rename this, boom, other. Maybe I should have it static between two and then call that one, but it's fine. Here, let's take the Y. So this now becomes if Z below brick and X intersects brick. Does it need to intersect on two? Yes. And Y intersects brick. Okay. And now, basically I can do yield return brick, and like to determine how far it can go down, we would have to take the max Z. Max Z out of that. I think. So if I take like boom, 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 this would be a int lowest z possible. For intersections is below me other bricks, and then we take max. Public int min z min location location dot z and location dot z. Let's do it like this. B dot max z. Could actually this or max z. Because this might not have any results. So calling max on an empty thing, if it can't cast to a thing like this, I think this one would work. But let's try this. So basically I need to write a bunch of tests now, just to make sure that all this code works. Public static void test. Okay, so let's do brick A is brick parse. Actually, I can just do new brick. And this one will be 0, 0. We don't need Docker. Let's see, 0, 0. Oh yeah, it needs to have a new location. New location 3D. 0, 0, 1. Because the lowest plane is lowest z is 0, and that is the floor, so nothing can exist there. It needs to be at least 1. The size will be new location 3D 0, 0, comma. Actually, we don't need to do this. We can do. It will be. Let's say it's 3 in the x-axis, which is fine. Oh, this is so annoying. So now I wish that I had done the other way around and just have the other constructor. So let's just do that, because it will be a pain otherwise. Public location 3D get init. Public get init. Public blah get init. So now we have a constructor. Let's make a second constructor that just takes these two. So we do public brick, and this one will be this. Now we can do end location is this, location is location. Come on, location is location. But this one needs to be lowercase actually. because now they are parameters. Like, the record stuff is fine, but it also gets a bit confusing at times. So now we have this one, we don't need to do this anymore. So this cleans up better like this, and now we can do, at least we can do this. We have our brick, and we have brick B. Actually, I need to put this one up in the air. So this one will be at x10. We will put this one at 3. Now I should make all sorts of complicated things like this. So this one should overlap just like that. Let's make one that doesn't overlap, because this one will start at, say, 7. Actually, it's inclusive there. So 3. Yes, my end location needs to be. Let me see. Actually, I need to do the size thing. Needs to be like, it always needs to have a 1 because it cannot occupy an empty space, but every value needs to be -1 for combining it. So boom, 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 boom. Let me see, how do I do this? The brick. I have a constructor here, right? Location 3D. This one, yes. Let's have a public static location 3D. How we call this? 1. I probably need to have an operator here as well. Minus. Boom. Like this. So the end brick would actually be the size -1. Like this. Yes, okay. Because all the values are inclusive. Linked all on Discord, we'll just get something to eat and watch your stream. Thank you. Enjoy your breakfast, or yeah, I think it will still be breakfast, right? We're in the same time zone. Let me see. I have done that, that, and that. Sure. So if I make this one 6, this one should be from 3, 4, and 5. This one should not overlap anymore. So if I do let me see, if I do a dot below me new blah, and let's do b comma c. And actually, I think, can I just do like dot dot b c? No, it doesn't like that. It's okay. Far below is this to array. Debug that assert below that count is 1 and below 0 equals to b. Length, my bad, length, like this. Then we have a dot lowest c possible for, let's just put this as other bricks. Other bricks. Above other bricks is this. Other bricks. Lowest z equals to this. Debug that assert lowest z equals to b dot max z plus 1. Actually, yes, that's a good one. I would be off by 1 there. Let's see. Lowest possible z would be this. Or otherwise it will be the current z. So it will either be the biggest one we find plus 1, or it will be our current. Okay. So now let's, where did I have the test code here? And this one should be a.max z. So let's put this to the test. 22. And let's do brick.test. Let's see what that does. Okay, below me is 0. Okay, that is not good. So let's see, brick B. The location is 303. Then it's 503, which is fine. Okay, set next statement. Let's debug this one. Add watch. Okay, then the x intersects. Add watch. Oh, the x doesn't intersect according to my code. Okay, let's see where that happens in this one. Okay, so the x intersects for this one. This one would be brick B. So I mean that. Okay, let me just go F10. So here we say x needs to be smaller or equal to. And locate. Wait, what? Ah, I'm at 0, 0, 0 going up to 2. Yeah, okay. My code is correct. Okay, never mind. Never mind, this is fine. So I need to do actually 1 like this. Boom, nice, okay. So the basic grid logic that I've written here works, at least in that case. Let me see if I do this one, it should it should break again. Right, okay, so yeah, this is fine. Okay, cool. So the basic rudimentary test that I've done makes me believe that this should be okay. So what I now should be able to do is parse out the input and then see how far they can fall down. The problem is that I need to go from the lowest Z up. So let me do that. Order by x.z, low, no, highest Z, Z max, max Z, okay. Yes. So this one takes the one that has the lowest Z and will go up. So this one will make sure that we be able to do the falling down properly. And I should not call this X but B because we have X, Y, Z. Let me just make sure this is an L for a line and not use X in this code because it will mess us up. Oh, okay. Didn't have the best sleep tonight, so sorry if I'm a bit sluggish today. Let's make the bricks fall down. void apply gravity. Right, let's do it here. Bricks. Boom, 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 boom. Ah, this is interesting because I will have to actually alter those. So do IEnumerable brick in this case. So let's go for each var brick in bricks. No, this will become a list of brick because I build it up as we go. I can just actually call this IEnumerable brick like this and do result is bricks to list like this, and then I can do result of remove brick. Actually, I need to make sure that I can do it differently. So I can, let's do a brick dot lowest possible z with result. Int lowest z is this. If lowest z is smaller than brick dot max z. And remember, this will be the max z if it's itself. We can shift down. So we remove it and then we do add, but we do with this, and this one would be, oh Jesus. It might just be easier to make a new brick here. New brick, and this one will be brick dot location, no. Minus 0, 0, still part 1? Yes, still part 1. Oh, I can do width, and then z is lowest z. Lowest z minus brick dot size dot z minus +1, right? Something like this. So if we're at 10 and we say, okay, we can go down to 4. If our height is 2, that means we have 10 minus 2 is 8, and then we can go, actually no, lowest, yeah, because we have the size, it will always be in that direction. So the lowest z would actually just, no, it would actually be correct. The z would just be the lowest z possible here. And then we still do brick.size because we don't change that one. Yes. For all yeah, all we do is just change the z in this case. And we change the this one. So this one makes sure that we process all the bricks, and then we shift them down and add them to the list. So this one will always have the latest reality of having all the bricks shifted down. So let's just do this one and do console.writeLine can go to z new z this lowest possible z lowest possible z, and this one will be brick location. Return result like this. So let's see. Var dropped is apply gravity to bricks. No, bricks. Let's do this in part 1 actually. Console, right line. Actually, we don't care. Let's run this and see how many bricks we can drop. None! Great. Not sure if my code is correct then. Let's read this one. Did they say which one will get dropped? At the time, it was a snapshot from the side. Axis go left, right. These bridges are arranged like this. So there's nothing on level 7. So G should be able to drop there, right? Yeah, see? So B and C compresses together, and then you have D and E on the same level. Okay. So we have to do this again. Set next statement. And let's just see. Let's see the first brick. Should I name them as well? This one is 111. That would be. Is there even a 111? Let me see. Oh no, it's 101. The end location is 111. Sure. So there's a 101 with this one. Yes, okay. So that's correctly. Also, no, I parsed this wrong because these are the. I need to have this one -1 subtracted from this one is the size actually. And because there's 0 base, subtracting there is that's also interesting. So I need to work on my math a little bit here, because the stuff that I do isn't fully correct. So if I look at all the bricks here, and it might be a bit hard to read like this. So you have 101. And the size is called 121, but this is not correct. This is the end location, and I need to deduct the size from that. So what I should do is actually remove these from each other and then add 1 would be yes. So my brick parser is wrong. Let me just fix that for now. Boom, 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 boom. So let me see, I have this one. This would be location start. This would be location end. And I should probably sort them so that I have the smallest one first. But let me just do this for now. This one is location end, and then size becomes location end. Come on, location end minus location start plus 1 location 3D 1, like this. This would be the size, and I need to take the absolute actually from this. So let me just make a function here, public location 3D apps. This one will return yes a new, and this one will be math.absolute x math.absolute.y math absolute z, like this. Boom. Yes. Okay. Okay. So this is, at least we have the size correctly, and I probably should have sorted the XYZ here. I wonder if the inputs have a tricky thing here where the one is smaller than the other, or if they're all nicely sorted. Looks like they're all neatly ordered. Okay, because I was thinking like there are basically two positions, so what I could do is just have something that ensures that it's correct. So what I could do is have in the location 2D, I can have a public location 3D A, location 3D B, and then I do sort, which might look weird, but then we do like this, and then we return to new this location 3D, comma this. We do this twice, and then we do the math.min a.x b.x math.min a.y b.y math.min a.z b.z, like this. And we do the same with the math maxes. And this one will ensure that every pair is in a way that we expect it. So like if you have a 1 2 1 going to a 1 3 1 going to 1 2 1, you can just swap out those pairs, because it's like a from and to range in 3 axes. They are 3 pairs, so you can treat them as 3 pairs. And this one will make sure that they are ordered in the way that we expect them for all our logic. So I can actually do location, comma, and location equals sort location dot sort location start location and. Alright, I think I can do this. Okay, at least this should now make our logic perform a bit better. Object reference not set to an instance of an object. Okay. Location 3D. I need to have the. Didn't I make it static? Okay, static, my bad. So now that we drop something, no, we still haven't dropped anything. Okay, bricks, back to the input. Boom, boom. Yes, that is correct. The dimensions are at least correct. Let me see. Put it side by side, it makes it easier. Let me two. That's not it. Let me just pull this out for now. Let me see. So just to validate that this is correct, from 1 to 1 to 1, 002 goes to 202, 0 to 3 goes to 223, 004 goes to 024. Those are just the parse values, and I think these are correct, like the dimensions here are correct. So this will let me calculate the cube size, etc. in the end. So it's not really relevant now yet, but I think it might come into play later. So now the only issue is, why doesn't the intersection work? Because they say here that, for instance, G should always be able to fall down there, because there's nothing at 7. So let me just see if I take that last brick. Boom, 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 boom. Set next statement. This one, okay. Lowest Z possible. Ah, shit, okay. Set next statement, step into, okay. Ah, if brick is this, continue. Let's try this. Do we now get some results? No, we still don't get any results. Okay. Let's go back and test that last case. Set next statement, step into, okay. Is this the case? Yes, okay. Step into, okay. Add watch. Let's get rid of all these. Let's set up our watching code here. Okay. Oh, actually, if there's nothing below me, I should actually return 1 here as your max C. So this one is actually the good result. 0 plus 1, like this. This would actually be the result, because if there's nothing below me, we would return that. Yes, I will rebuild and apply and then do all the stepping again, which is annoying. So 1, 2, 3, 4, 5, and then I need to do one more. Okay, step into. This operates on IEnumerable, so it will go into here every time. So that is annoying. Which brick should at least intersect with this one? So at least this one. Should I be able to have more intersections? Probably. Well, let's not worry about that. Let's just check the case that we know that has to clash there. Oh wait, what happened here? I did let me see. If this dot z location dot z is 8 and brick that location that z is 6, console system that diagnostic that right line okay, let's run this again. There's an 8 and a 6. Why didn't it trigger? Lowest Z possible. Below me. This one. How is it possible that this doesn't trigger? Did I do the sorting? Yeah. That is really crazy. Okay. This is getting annoying. The other bricks. It has a Z of 8 and this one has a Z of 6. Why are they never compared here? Okay. Other bricks is 7. Oh, wait. This is weird, they are all mangled now. Okay, so there's something wrong here. So now I know why there wasn't one, because these all got weirdly mangled. And the size is good. Okay. What happened there? Let me see. So at this point they are all still correct, right? Yes. Okay, so does something happen to the values here? No. Okay, so now we have 1. Lowest Z is 1. Okay, this is interesting. So we have the 0, 2, 3, 1. Okay, let me check. Why didn't it appear in our output? The 0, 2, 3 C here, and it says that C can drop, which is true. C could drop 1 here, right? It can go down 1 level, so it starts out at 3 and it can go to 2. But it shouldn't be able to go to 1. Let me think. The brick here. So I wonder why it said that it could go down. Because it should stack on top of A. So C should at least stack up on top of A. Like this. So the X has an overlap, and the Y should have an overlap, and the Z doesn't matter. It's an interesting case. Let me see. Set next statement. Step into. It says it doesn't intersect on the y-axis here, which is not true. Let's see. Location 023 to 223. That was correct. 023 to 223. And this brick goes from 101 to let me see, the Z intersects. Let me see. I should probably just compare two ends in this case. So this becomes brick. Not Rick, brick. Same here. Brick. Okay. So what was brick dot location dot location at y? Location at y. Okay, let me see. Because you just need to compare the ends, right? Ah, I need to compare this to end location. Let me see. This needs to be end location here. Right? This one, they need to cross, like end location needs to be larger than the start. Yes. So you need to cross them. Okay. I think I got my intersections better now. So what is the lowest Z is now 2. Great, that's what we want. The only thing that I didn't like was, okay, cool. Okay, let's see. Whew, got there in the end. And I've written that intersection logic so many times I should just put it in a function somewhere. So 0 to 3, C drops down 1 spot. we have the 004 one, which is D, that also drops down. Let's see, what does D and E do? D is 4, D drops to 3 as well. And what does E do? 04 is the 205. Yes, they both go to 3. The 016, this one, F. Oh, that's not correct. Can now go to Z2. F should not be able to go to Z2. That needs to stay at 4, so we have to figure out what's wrong there. And this one goes also to Z2. Okay. Getting there. So we have some correct, some not so correct. I think I need to make sure that I validate the new bricks. Here, bricks that size needs to be end location. Can I just do brick with location? Oh no, that also needs to update. Sheesh. So I should need to make this right. I should have like a brick dot move down, and this would be brick dot max C minus lowest C, like this. Well, let me just add this here and make that function. So let's do public brick move down int z steps, like this. Location with z minus z steps, and then why doesn't it like this? Let me see. Can I do just location? With z is this that location with z is actually, yeah, z is this that location that z minus z steps. This is what I want to do, but for somehow, what is the error here? Only assignment call can be used as a yeah, okay, sure, because I want to feed this into this. now it likes it. Now do the same for end location. Okay. Got there. Let's see. Boom, 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 boom. Ah, okay, great. This looks better. Let me see if this gels with what it should be. Except it steps 2 down instead of... oh yeah, G goes from... So let's see. F goes to 4, G goes to 5. Is that correct? F4, G5. Woohoo! It works. Nice. Oh. Okay. So that is step 1 of part 1. And let me see, if I run this again, it should not do anything, right? Console.writeLine. Dropping again, expecting no differences. So let's do this. Okay. So that part seems okay. So let's also make this one okay. So now we just need to go for each of them. For each var brick in dropped, because this is now our new state. We can do if apply gravity to dropped except brick. So this keeps creating a new collection every time. What is accept by? No, okay. It's accept, and this can be just a new brick array, and this one will be an empty one. Okay. If this dot count in this case is 0, P1 gets incremented. Like this. Let's see, the test answer should be 5 in this case. 5. It's not. It's 0. Wow. That is interesting. Ah, no, it's I'm an idiot. So this will be a new state, and then we do int drop count. So let's do int drop count is 0. Increment drop count. Return var drop count. Okay. New state. I can just do new state in this case. We don't need to actually keep that. And then we do dot drop count Okay, let's try this again. And our answer was correct. Woohoo! Our answer was correct. So now run it on the real input. And we do this if test. Oh wow. It doesn't like what I'm doing at all. Jesus, call stack. Is it this horrible to run? Okay, apparently my code is very horrible. Because what I'm doing is actually comparing against all the others, and I only need to check what's above me. So yeah, the issue here is that I should check which ones are touching which other ones. So now this is really slow. Man, I didn't think it would be this bad. Okay, I created a monster. And I could probably just create another version of this that just stops as soon as there is one break. So let me debug detach all. I won't print out the output anyway, so I'm stupid. Okay, let me just put that here as well. Console, white line, P1, part 1. Boom, P1. Okay. Has no drops. Bool. Return false. Return true. So this is at least something. So we can do, okay. Let's do a for int loop here. For int I is 0, I smaller than result at count plus I. Len is this. Brick. Octrees for the win. But to be fair, that would be overkill. I don't even know what an octree is, so you will have to teach me. Let's see. Has no drops. Oh, I'm modifying the wrong thing here. This is for here. Dropped. Okay. Brick is dropped I. Skip I plus 1. Nothing that has come before it can be an issue here, so we can skip all of those. And this one needs to be has no drops. So at least this is a bit more optimized and should run a bit faster. It will still be slow probably, but it should be a lot less slow than before. If I percentage 100 is 0, console that right line, come on. Console that right line. What? Cancel. Was there an exception? Part 1 it says 1, okay. Really? That would be such evilness. Console.write line. Let's see. I out of lamp. Okay, it says my answer is 1. That would be... I'm just gonna try it. That's not the right answer. Okay. Dang it. Let me run the test again to make sure that I didn't break anything with my new code. Okay, this is also 1. It's okay. So I wonder what my issue is. Has no drops. True. False. No. Let me see what I do wrong here. Forgot an octree no two branches may overlap. That's why search is faster, because you can select branches by lookup position. Okay. Let's see, with octree you organize your space into a tree of volumes such that root contains everything. It contains 2 or more branches with themselves containing smaller branches given that object. Our bricks, those can be leaves. They could search for any given brick faster because you could traverse a tree and not deal with all the bricks. Okay. I'm just wondering what I broke here. I'm looking. I know what I did wrong. I did a skip instead of a take. This one needs to do take I, and this one will. This one should now work again. Except it's 7. Let me think. This one is sorted, so I should never have to look to stuff above me. So is my sorting wrong? Okay, wait, this says 5, so why is my... because I need to count from the first time. Oh wait, I don't need to... No, applied gravity is correct. My drop count coincides with the disintegrate thing, so let me see. No, wait, I'm doing things the wrong way. Here, let me see. It should be skip because this one needs to... No, I can't. I still have to do the accept thing. Okay, my bad. Dot accept new. The thing is, I should probably map out which brick actually touches the other ones. And then just compare those. So I will just let this run now, because it should be a bit, whoa. Part 1.5, okay, yeah, that's fine. Let's run the test, the real input, and see how slow it is. Pretty slow, because it won't even print out 100 yet, and there's like 1500 of these. Oh god. Okay. Oh wow, wait. That was 0. Where do I print this? Okay. Okay, the dropping one was slow. The dropping code was slow. This one is now fine because I exit early. Okay. 0. Okay, I'm just trying it. How come this is 0? Okay, let's see. Console.writeLine expecting no more drops. Dropped is apply gravity dropped. Var again is this console.writeLine dropped again dot drop count. Okay, let's see if this one spits out something. Submitting something 0 is something I never expect. Well, they could have just had like a haha, this is part 1, and then now you have to do this, expecting no more drops. So this could be due to the way that I run it with the sorting stuff. Dropped again, 800, okay. So that is weird. So let's see, okay. Var d is this. While d dot drop count larger than 0. D is apply gravity. D dot new state. I don't think that is something that should be able to happen, but let's just do it again. Var dropped is the new state. Okay. Console.writeLine still so this will be very slow, but let's just d dot drop count. And now I wonder why my sorting, because it's sorting on Z. So how could that affect things? Oh well, we'll see. Oh my god. Well, we're making progress. It's an iterative approach. Huh. Oh my god. There is no rotation involved, so there's something very stupid in my code. Okay. We finally ended up at a state where everything is fully dropped, which is crazy. Ah, so it's my overlapping. Could it be my overlapping code? I don't know. I should make it print out which ones it does after the first one. Okay, so now this is super slow. Well, before it was not that bad. It was... Well... Ah, because below it would constantly find things that could drop. So yeah, okay, my bad. We might be here a while, folks. Let me look at... just to see if code is really standalone logic, transferred to AOC console app, it still yields good results. Good results, okay? Okay, I will check that after I've done it to not get spoilers here. How do you apply gravity? Sorry for didn't see that part of the coding. Yeah, no worries. Let's just this one heat up the room for a bit. My apply gravity works as followed. So what I do after the input, I order them by having the one with the lowest max z. So it will be sorted in a way that the one with the lowest max z will be processed first. And my thinking is you can only be blocked by things with a lower z than you have, right? Everything at the same level or above doesn't matter. So if you sort it to just have a lower z, it should be fine. But what I didn't account for is that if at the same level it would drop more. No, I don't know, I'm not sure. Apply gravity, it just loops through all of these and then it will do this lowest z possible and it will filter back in the entire list. And this one will check this one below me. And below me it will just, should remove this. It will skip itself and it will return every brick that has a z below the current one where the x and the y intersects. And I might have a bug here in my intersect logic that it's too greedy. But I think these need to be inclusive here. So you have, you make sure that the other starts at your end or earlier, and you make sure that the other one ends at or after your start. And we do this for x and z, x and y. So I return all of those, and then I take like the highest z value there, because it for the thing that you intersect with, it takes the highest z values of that pair and it returns that plus 1 as your new target z value. So if there is something below you that would block your path, it will return its highest point plus 1 as your new lowest point. That's how it's done here. So it returns your lowest Z possible, and then it will use this move down. Let's see, okay, makes sense, but I'm worried about sorting against max Z instead of min Z. This would make tall cubes sort above smaller cubes. No, but this is sorting ascending, right? So you get the smaller cubes before the tall cubes. So you get the smaller cubes before the taller ones. If this is your plane, and you have one that's like this, and you have one that's like this one will be sorted before this one, right? Because it's sorting in an ascending way. Lowest value comes first. Let's see. Oh, if the tallest sits lower. Okay. You have a valid point there. I'm an idiot, as always. So my sort should be the other way around. And this doesn't even do 100 checks. So yeah, let's abort. Let's make sure that the sorting here goes by order by min Z, then by max Z, like this. So now at least if I run it, it should only do the gravity once. Nope. But that went a lot faster, which is weird. So that sorting still didn't matter. Don't say that, we sometimes make mistakes and learn, yes. But it's funny how this now runs faster than when I had this one. So if I do dot order by, oh, this one was slower. No. Why is this now so fast? I could have sworn that this was slower before. Okay, never mind. So we go by min Z, then max Z. And apparently it doesn't matter. Oh wait, this one is the culprit. Let me think. Because this one now gets entered at the back, so I should probably insert this lower, or at least can I do result.sort? Min Z minus b dot min Z. Because now the one in the end, okay, let me just do this. Is it now reversed? No, it's fine. So at least the one that's added in the back. So this one should help here. But I would probably have to do, more efficient would be like a binary tree insert. Structures the entire sorted for an element using the default comparer. Funny. Well, actually, this one isn't perfectly sorted now, but it should be okay. Do you check it against cubes that are already processed and as much down as possible, or any cubes? I just checked the entire list here. Let me see if I run it like this, apply gravity. Oh, it still does that. Weird. Even when sorting it. And it made the codes slower. Which is funny. Let me think. So for now I'm just going to, and I wonder how bad this would be if I just did an insert at the start. Just insert them all at the start when they go down. It's probably not correct. No, I shouldn't do that. I should probably just sort it once in the end. And then be fine. Let me see. And now I need to make sure that I can map which bricks is touching which other bricks. Let's see. So I need to compare two bricks and see if they are touching. Public bool r touches brick other. Bool result is false. Return result. Basically, this becomes like other dot min z plus 1 equals max z, like this, or other dot max z equals min z plus 1. Bool z connected is this. So this is the first part, and then we need to make sure that there is an intersect between x and y. So that one is easy. So result would actually be bool intersects. Is x intersects with other and y intersects with other. So then result becomes, you can return z connected and intersects. This is basically the logic to make sure that one touches the other. Let's just call it load bearing. So now we just need to build up those pairs. So let me just whip that out. Let's have, first we need to do this, and then we need to have a dictionary of brick with a hash set of brick. And this one would be load bearing to each other is new. Okay, so now we do var permutations is let's put dropped here actually. This dropped permutate 2. Allow do false. Okay, for each var pair in permutations. Okay, if pair dot okay. Pair dot as value tuple. If a load bearing B, if load bearing to each other, try get value a comma out a list. A list, come on, list is new. And then we do load bearing to each other dot add a comma a list. Same for B. And we do a list dot add B, B list dot add A. Now we have a cross for everything that we need to check. Like this. And once it's all connected, everybody should have one. Because every brick is stacked on top of another. So, so now do the same as here, except we do this one. Load bearing to each other brick. This one should speed it up a whole bunch. Boom. The given key was not present in the dictionary. Okay, that's interesting. Which brick is this? 071. Okay. Not try get value brick out var load list or load list like this. Okay, and the answer is 10. Not the right answer. Jesus Christ. So at least it's faster now. Let's run the test and see if my test works. Nope. This one gives 0. Ah, wait. I need to, those are the ones touching, but I need to make sure that those don't fall down. I wonder if I can shrink the search space even more. But basically what I have to do is now, for each one of those, test. Yeah, I can do that. Let me see. Like this, else. For each. For brick in, for other in load list. I need to make sure that these don't drop without the other one below it. And I wonder if that just means yes. So let's say below equals dropped.take I. Like this. And now I can say apply gravity. This one. Is this correct? Let me see. What is it complaining about? Let me just stop running now. Did I have a semicolon wrong somewhere? Something? Okay, it doesn't like this at all. Okay. Why not? Because isn't this like the new spread operator thing? Okay, never mind. It's fine. We do apply gravity to below concat other. Sure. Actually, I should just concat load list here. Isn't this what we need to do? So we take everything before except the one that we're testing now. We need to take everyone that's directly above, connected to it, and now we test this. So this will run increasingly slower, but 3, almost. Like if you look at the logic, like if you take one brick away, the only one that can be affected are the ones directly being supported by it above it. So why doesn't this work? Because what I do is I take the below, below doesn't contain, let me just make sure here. Okay, let's run once more. Below should not contain this brick, right? Below will have one entry, 010, and brick is not 010, right? This is the next one. Okay, that is fine. True, but only those that are supported by that brick alone. Yes. But my problem is that I'm not finding all the issues, because I'm for some reason I come up with 3 instead of 5 when I run it against a test now, which is weird. So there seems to be others that are not in the load list that can drop, which is weird. Else, okay, let me just do this. If apply gravity, and this one will be below, no, this one will be dropped, not accept. This one. Console.write line. This should never happen, but it will happen, so let's see. Right, so here we have it. We have a brick, 101. It says it has 2 connected to it. Okay, let me see. Brick is 101, right? Let's go back to the debug here. This one. What stacks on top of A? B and C, right? It's just B and C that stacks on top of it. Ah, but you need to have the ones connected to that one to know if it would be an issue, right? No. No. Let me see. We are checking this one. The only 2 that can be affected by dropping A would be B and C. It supports B and C. So in my code, the below list is 0. It has the load list of these 2. So how can this one, okay, wait, this is weird. How can this one have a drop count of 0? It has a drop count of 2. Wait, what? I wrote this wrong. Okay. If this one is 0, then I need to. Never mind. Okay, back to the drawing board. And then I also need to do this, but here is the one that's wrong. So we have the 002. Let's see, the load list is 3 for them, so 002, let me see. 002 is classified as, which label? 002 is classified as B. Let's see. B supports D and E, and it is supported by A. So in my code it would return all 3 of those. So the load list should be 3 of them, so yeah. So those are those 3. If apply gravity larger than 0 instead of 1. Yeah, I had that wrong. This one, if the drop count is 0, you can remove it. This is what we want to do. But in this case, we ran like below is one entry. So we say that below B is only A, which is correct. It's the one that came before it, so this should be index 1 now that we're doing. Right, I should be 1, I think. Yes. So below is just the one that we processed before. It's also the one that's below it. This one will have a duplicate here, so I should probably make a unique set here. But yeah, still, there should be able to have a drop here, going from... Oh wait, maybe it's not concat, it's union actually. What is the drop count here? Okay, so this is fine. So how come this one? Like you can't remove B, right? Let's see. They say B can be disintegrated. The bricks above it, D and E, would still be supported by brick C. Okay. So my issue is that I need to extend my search there, because the issue would be that I don't have the next door neighbor. So what I need to have is the below, including the union of load list, and then I need to have the load list for each one of these as well. Okay, so var to test is this. And then I need to do for each var other in load list. To test is to test that I can do union with, union by. Sure, it's fine. To test is union, and this one would be this one. Jeez. If this one other load list like this, and now this should be the logic. So I need to extend one out to get everything connected there, and it still doesn't work. Jesus Christ. Why doesn't this work? So I'm testing for brick 1. And I'm testing each other one that's connected to it. Ah, this needs to be other. My bad. Okay, my bad. Okay, now it works. But my answer is now 7. That is not correct. Is it this case that's causing this? Let me see, how much does that happen? Never. Okay. So how come now all of a sudden it thinks everything can be dropped? Because I still need to... Okay. Remove... No. I need to still need to remove this one. Because that one will be added back in due to all the neighbors. Okay. Okay, now it works. Crikey. Now let's see what it does with the real code. It's starting to feel painful, but we're getting there. Now, this should be a bit faster, but I don't know how long it takes to... No, actually it got here, so the permutations have been done. Okay. So it works. It's slow, but it works. Let's see what it spits out for an answer. Man, I wish this was faster. Like for one of those other days I was like, how can you write code that takes 20 minutes to run? And then today I'm like, how does this take so long? Okay. Let's see if we can at least complete part 1. Come on. Okay. Let me just put this on screen here. And go make myself another cup of coffee. I'll be back in a bit. And I'm back. Thanks for waiting. And here's the cappuccino. Okay, I see we have an answer. Which is not that high, but let's see if it works. No! It's not the right answer, Jesus Christ. Oh, how is that possible? Dang it. Because you have guessed incorrectly 4 times on this puzzle, please wait 5 minutes before trying again. Okay. This is embarrassing. Oh man. Okay. That's not the thing that I wanted to pull up. Let me see. At least this case never triggered, so that logic was correct now. Ah, but it still executed all of this. Haha. Okay. This would have made it very slow. Okay. I was like, why was the code still so slow? I mean, it still isn't great, but it's better than it was. And I actually think that I don't even need to take out... Okay, let me see. I think I can just skip the whole below thing. And this would just be load list to array. Like this. Boom. Oh, now we have 19, so that for sure isn't correct. Because I thought like, okay, if I have everything connected to it 2 layers deep, that should be enough, right? To know... My reasoning behind this was, okay, if I take my current brick and take everything that is connected to it, and then everything that's connected to that, that should give you everything that interacts when you remove one of those, because you're 2 layers deep. 5 minutes wait, just run the code again. Yeah. Okay, let me see. So how many levels deep should I do this? Because my reasoning, like if I go to MS Paint, let's say you have a block here and a block here. And you have a block here. And then something on here, and something on here. And you have another one here. Like if you want to inspect this one, and you take all of the things that's connected to it, and all of the things that's connected to those, shouldn't that always give you enough to know all the connections, so that if you take it away, that what would happen to this one? Like it has to be directly supported by another brick in order to not fall if you take this one away. So if you take everything that's connected to this one, you should be able to know what happens to that one if you take this one away. And that is basically what I think I wrote, but it doesn't seem to work, which annoys me to no end. So that's what I do here, right? And that's why I don't think the below should be needed at all. I get like the current list, everything that's connected to it is the load list. If there's nothing connected to it, great. If there's something connected to it, get everything that's connected to that and sum it all up together and then check what happens if you pull one away. And in my mind, that should be able to reason about the full logic. So I don't understand why this doesn't work. So for me it would be load list to list. Something like this, right? Boom. One level. I'm not sure what you mean by one level. So for me, like, I don't think this one should be needed at all. But if I do that, I just get 19. But for my reasoning, I'm getting everything that's possibly connected to every one of these as well. So I don't see how I wouldn't be able to reason what would happen when we remove this one if we have all this data here, everything that's directly touching. So the only thing that I can think of is that my logic for making things touch doesn't add up. And the other thing that bothers me is that the sorted thing that goes down doesn't catch all of them. Why not get all the bricks above the current, then for each one check if that brick has only one supporter, that is if it lies current, if it lie part of it is covered by an emoji. I really hate that about the YouTube thing that they add. Makes it hard to read. Let's see. If it lies on the current brick only, all connected above. Why everything above? Because you can only be supported below, right? So like, I get 2 degrees of separation with this logic. I start from here, and then I take everything connected to it and everything connected to that. That should give me 2 degrees of separation. So if I remove this brick, I should be able to reason about what happens to everything connected. So the only thing that I can think of is that my logic here, the load bearing to each other thing, that this one doesn't catch all the cases. That's the only thing that I can think of that would make this not work, which is a pain. Like this load bearing to each other. This is the time where I want to start a 3D engine and visualize it. Let's see, you have a current brick. You want to check bricks above, if any fall, if you move the current. But bricks that, if you remove a brick, only stuff that's connected directly to that brick can be impacted. If it's not touching the brick directly, it cannot fall. It can only fall if a brick that's touching it directly falls. Because if the brick doesn't touch it directly, gravity has no effect on it because it's already supported by something else. That's what I say, like, I have this. This is the brick that I inspect. I get everything that touches that brick and everything that touches that brick, and that should be enough. So, yeah, I don't check everything because if it's not connected to this brick, removing it can have no impact. Like anything that's not connected to this cannot be impacted directly at first without being affected by something that's connected to this. Like this one can never be affected by removing this one because this one will remove this one and then this one will make this one do something. But without this one being affected, this one won't have an effect. That's what I mean, like, you only need to check in your direct connection to the current brick, and then you take in everything connected to those bricks to see what happens if it would take. Now actually, see you. Yeah, but because you need to have everything connected to the brick to make sure that that one is supported. So by taking everything that's connected to that brick, you get all its supports as well. So if this one goes away, the other support will still be in the space, and it should be fine. But for every brick that is supported by current, all you do is to check if the above brick is supported only. Oh wait, by the way, I know the issue. I do apply gravity, but I don't have the full tree down, so it will always do a down. So what I need to do is set a new gravity. Not by applying gravity, but by checking coordinates. Actually, what I need to do is add a fake wall. To do make fake floor so bottom won't fall out. But even then, when I checked the full range, it still didn't work and come up with the wrong number. So I can just do this, remove this brick. For 2 tests, I need to get the min. Let me see, the min XYZ, and then the max XY with the min Z. Min Z. Okay, this will be our floor. Int min Z is this. So now we do 2 tests dot add new brick. This one will be new location. Zero comma min Z. To test of max. Like this. So this will make it a fake plane where everything can rest. Because that was causing me to give out false positives there. This is the end location. This, and I need to do the min X and Y here, because it can go negative, of course. Well, it could go negative, but let's just make sure that we have a supporting plane here. Boom. $21, haha, okay. And this one actually needs to be -1. 25. Okay, getting better, but still not what we need to have there. The test case is just too small for me to catch a bug in it, I think. Because this one works, but yeah, that's just because the test case is too small. Do I want to compare this? And then I want to do drop result.accept new state.accept to test. Let me just actually do this one. Far below, this is actually this one, and then we do far below is this, and then we do to test at add range below, and then we still need to remove this one. This is the case that we want to see, where we catch it if we take the full scope, but not when we do the local scope. Okay. Let me see. Local dropped. Let me run this again. So there are two bricks here that were dropped that were not part of that weren't dropped in the other case. Let me see. Local dropped 0. No. Local dropped 0. Local drop 1, and we have our original to test. I modify it. I should not do that. Far to test 2 is below that add range. This okay, let's do another comparison here, because I'm curious to see where the data comes from. So we have these local dropped R2. So I wanted to see like two tests. No, a load list. Load list is 2, and the one that dropped were not part of the load list. That is fine, but I wonder if load bang to each other, local dropped 0. Key not found exception. Okay. So for some reason, this one is not connected to anything according to my code. Load bearing to each other, local dropped one. So both of those don't exist. So those are interesting cases. So that means that my load bearing to each other logic is not correct. And that I'm missing something there. So let's see. Let's see if we can find these. So let's see, var brick is, well, let's just write a test function here to figure this out. So void test, var a is new brick. Like this. Then we need to have the end position, which was 5, 8, 1. B, this one is 2, 8, 3. And this becomes 5, 8, 3. 2, 2. Okay. So we need to have bricks where b dot z max max z is a dot min z plus minus 1. Var just below a is this dot to list. Okay. So this should give us all the candidates that could support A, just below B. I'm so smart. Let's just call it T here. This one needs to be relative to A. So var match A is just below A dot select load bearing A, like this. A just below dot count and then match A dot count. I just make sure that I reference each one of them so that the compiler doesn't optimize them out. Had that before. And then let's just do after here we do test and then return. Okay, what is the issue? And I want to do test 2, not test 1, because boom. Okay, let's see. So the first one doesn't match anything, but the second one matches something. So how can this one fall down when something else is removed when there's no direct connection? So this one is wrong. The second one is interesting because when I checked, there was no reference for this one. So either the permutations thing messed up or... Let me see. So just below A is nothing. How is that possible? Ah, because the Z is at 0. This one is a ground block. This one shouldn't be able to fall. How did my logic think that it fell? That is interesting. That might be even more interesting than figuring this out, because that is just incorrect. Let's see. Let's run this. Okay, so local dropped. These are no longer in the same place as they were. Oh no, it dropped down to 1. It didn't exist there. My bad, my bad. I need to have the original positions. And for this one, local dropped original. This to test except this one. Okay. Let's run it again, and then I need to do another set of tests. So now if we do load bearing to each other, local dropped, original 0. Okay, see, now there's data. Okay. I thought it was going crazy. But this one doesn't. So that is interesting. Original. Okay, so let's take this one. So the first one has data, so it's interesting why that dropped, because it shouldn't be able to. Because this one has these connections. Let's see, what is brick? It's at x5. It's at Z5. So how is it possible that if we remove that one, that this one drops? So that should not be possible. Ah, because there's an issue with the logic that I made with the let me think. My fake plane didn't work. So now I kind of want to draw in 3D. I want to whip out Blender and or Godot or Unity and just visualize it. Well, you could take 2D slices. Maybe that's the best idea. Yeah. Huh. So the weird thing for me is that there's one thing here that, according to the logic, didn't have any supporting members. So I can still chase that one. But it also means that for some reason I didn't get support all the way to the ground for every one of them, which is weird. So let me just take these now. Okay. Two, 8, 5, going up until 585. This one is 582, and this one goes from 3, 7, 2. And this is what I think is really weird, because this one tells me there are actually matches. 6 to be precise. And they all... How is it possible that they all are load bearing to that one? Now I'm really curious to see why this one matches. Jesus, it falls to where? Set next statement. Okay, let me see. They both have 1 there. So how is it possible that I do that on the dropped versions, not on the original bricks list. Let me see if I do that properly here. I do dropped permutations, then load bearing to each other. Let's see. What am I doing here? Load bearing to each other, A load bearing B. So this is just comparing those two. Which should be fine. But still somehow... Let me see. String.join. And this one will be match A, like this. And I can just do dot location, actually dot location, no, 0, okay, dot select. This. Because the location should be the key for everything now. So now I can also check in this permutation code to make sure that I can break here. Location 3D log A is new this, and then we go 2, 8, 5. Log B is new this, and that becomes 4, 6, 4. So this is one pair. A1. Log A2 is new blah. 3, 7, 2. Log B2 is new, and this one becomes 4, 6, 4. Okay. So now let's see if we can catch those pairs. If A equals log A1 and B equals log B1. Location, okay, let me just say location. And then we need to test the inverse as well. Or swapped, or, and then we do the same for the V2 versions. Okay, console.myFile. Okay, so for some reason they don't come up as permutations here. Let me see. Quick watch. Dropped where x dot location equals log A1. It exists. B1. It does not. That is weird. A2 does not exist. And B2 does also not exist. Ha! So after all gravity has been applied, how come I get back original locations that don't exist in my dropped? Do I reference bricks somewhere where I shouldn't? Yes, here. Jesus. Okay. I'm not making it easy on myself here. Now I need to supply dropped here. This one returns 2, so why is my string join only returning 1 there? Am I... Ah, because I need to do a B, okay. Come on. Boom, boom, boom. Let me just drop these in Notepad. And let's see the first issue that we have. The original ones. Are those the issues here? Like 285, right? Okay, 285. Okay. So now I wonder if I take the load bearing for this one. Boom, boom, boom. That's the 3.8. Okay, no, that's different. So this is funny to me because it says that this one doesn't have nothing touching it. 372, was it in my test? This is in my test, right? The 372 one. And my logic says there are two things that should be touching it. So if I do load bearing to each other, where x at key.location equals new is actually local dropped original one.location. Okay. I don't see the issue here. Okay, let me see the call stack. We're here. Okay, let me do this. Ah, okay. So this is weird. It says it has no entries where it matches this location, 372. But 372 is here in my check. So what happens? What happened here? So I think the 372 one is one that I need to check. 372, this one. Let me just get rid of this and just check when it's 372. So if A is location 372 log A, yes. Or B.location equals log A2. Okay. Let's see what it comes up with here. This one. Okay, so it never enters the permutation thing, which is really weird. How is that possible? For exist is drop.where x.location equals log A2, right? permutations where x okay, let's do this. Let's try to get to the bottom of this. So it says dropped, doesn't have that entry. Which is really weird. Because if we don't have that entry, how can it be an issue when we do load bearing to... So this is all fine. This one looks at dropped, it takes dropped. And I don't understand this at all. Because this one tells me, hey, this is a value that you need to look at, which doesn't exist. This is so weird. How can we have these values here? This local dropped one. It comes from to test. To test is built up from load list, load bearing. This one comes from dropped, and dropped exists here. So I don't understand it. (372). This location. And the weird thing is when I run the test, it spits out that it has that location and how many times it has it. I don't get it at all. Let me see. Yeah, 372. We have 20 of them where 2 match. Okay, so if I run test 2 again here, does the permutations do something weird? Nope. Okay. It's really hard to understand why this happens. (372). Does the equality thing not work here? I mean, it's not in here, so I don't... It should be sorted by Z here. Oh wait, is it... (374). So A in this case Ah, it's a fictitious. Okay, it's a fictional brick. Let me see. Feels like I'm chasing my tail here. Because this stuff, this is like the drop result new state, but I should have the to test would be, this would be from dropped. Let's see if I'm mistaken here. So this one doesn't exist, and this one doesn't exist. I don't understand. The two test ones. Because everything in this to test should exist in dropped. Let me see. To test that union. No, not union. Is this only? Yes, I need to have a, what's it called again? An intersect, actually. Intersect of dropped. Valid is this. There are 9 in here. To test was 10. So 1 is no longer in here. So the var actual dropped is to test except valid. Okay, let's get rid of all this crap. Okay. Local dropped. No, we don't need that. We don't need that. Okay, let's run this. Boom, 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 boom. Okay, so this one says load bank to each other. It has none for this one. So this one was one of the tests, which is still, it's 372, which has no grounding thing. How can it be at Z2 if there's nothing below touching it? So this one is very interesting to me. And this is also like this case. So 372. How come 372 is into test? So this is what I'm curious about, 372, because it didn't come up in my permutations code, which is what I was trying to test. 372 here. And now I'm back to square one, where I don't understand where this is coming from, because to test lists this value, load list. To test is load list. So in load list somewhere is that value. This one is incorrect. No, wait. If A load bearing B, load bearing to each other A to A list, we add B or A. So how can... I still don't understand how we can get a permutation of that thing that if it doesn't exist. It's just driving me fairly crazy. Because it doesn't exist here. And it doesn't exist here. So how can it end up in these permutations where we do this load bearing to each other stuff? This is really, it's so strange that I can't tell where this comes from. See? So it does all these permutations. Then here, somehow it gets added to test. Ah, wait. Never mind. I think I found my ghost. Let me see. Var fake floor is this. Fake floor. So watch this be the fake floor that I create, right? Let's see, fake floor is this one. Yep, oh god, darn it. This one needed to be 1 followed by min z. Okay. Is it a different one now? Yes, okay. Whew, okay. So actually dropped is this one. 371, this is still the floor. How can the floor drop below 1? I don't understand. So why is this 0? This is my fake floor. Why doesn't it extend from 0 to 8? Because those are the biggest numbers I see here. So it should go from 0 to 8 and then from 1 to 2 so that it supports this one. Yes, okay. This one needs to be location.x, not end location. I need to have the smallest there, okay. Getting there step by step, but Jesus, this has been painful to debug. Okay, let's see. Actually dropped. It's one of them. Okay, let's see. Actually dropped. A Z1 cannot drop. Because there is a floor at Z0. (0.5 to 5.8). Because to test should be that range, right? 0.5 to 5.8, so at least that's a valid range. And then we go, the smallest Z here is 3, so we go from 1 to 2. So this one shouldn't be able to drop because Z1 means it's supported on Z0, which means it can't drop. So let's go back. Set next statement. Apply gravity. Okay, let's see. Lowest Z, max Z. Is this the brick that we're talking about? No. So why is lowest Z possible here too, when the brick actually goes up to 2? So it should never be 2, it should be, so this one is wrong. So the lowest Z possible here, come on, set next statement, step into, Z below. Sure. What's the call stack here? I need to have the function in between. Okay, let's see. So below me, max Z is the lower value closer to the floor. No, what this gets is every other brick that intersects with you, below you, that has a max Z lower than your min Z, and then it should get the max out of that. Let's see. I need to run this again and then set the breakpoint there. Let's see, was that no? I need to disable all my breakpoints so that we can get to the problem state. Yes. Now I need to do this again. So apply gravity, set next statement, step into. Okay. I need to have this one here. So now bricks below me should actually be just the one floor tile. Come on, to array. No, I think it's, oh, come on. Okay. So there are two below them, because what is my location? Z4, okay. So below me is both of them, that's fine. So this means that these two below here all intersect there. So now we get the highest is 3, so the one below it is 3, so we return 4 here. So the lowest Z becomes 4. And this is actually the brick, okay. And I need to set my breakpoint here. Remove this one, now set it back here. Go to definition and set my breakpoint here. So now this one, I think this one so this one is below it. And the max Z is wrong here. Okay, how is my max Z wrong here? So this is a brick problem. Let's see, max Z. Oh. Can you see how stupid I am? Can you believe it? The max Z function was wrong. Oh man, I'm so pissed. It's stupid stuff like that that always gets in the way. This is fine. Oh wow. Boom. Sequence contains no elements. Wait, what? How can this brick is supported by itself? That is weird. 310 with 112. It's also applied wrong. Oh no, it's right. From 0 to yes. Still, you get a max Z of below brick, so you should compare it to min Z in a pie graph where you move accordingly. I'm not sure if you... Let me just fix this one for the permutations. Because in this case A is B and it should not be possible. Let me remove all of this as well. Clean up a little bit. So this is weird. A Z of -2. So that is also funky. Ah, this is because my gravity thing is now broken. Which is great. Oh, I actually need to stop streaming because I have to go pick up the kids from school. I just noticed the time now. So sorry for that. I actually have to ditch and run because it's nearly 12:30. So yeah, sorry. I will continue this at a later date. Time has flown by, damn it. So yeah, thanks for watching and I hope to catch you later today maybe.